This is the Zoom for Heavy Civil, Thursday, April 28th, 7:30 p.m. I appreciate you coming in at the late hour. And so what we're going to do, the first thing we're going to do is tell you about the change in the homework that was due for tonight. I forgot to put a Dropbox in, and one of you nicely emailed me. And so the geotech case study, page 8, is now due tomorrow at 12 noon, not tonight at 11:59 p.m. And that was, in this case study right here, page 8. And there was just a bunch of easy questions. If you do have any questions on that, we can go over that at the end of the class tonight. What we're going to do tonight is we're going to go over the sieve test that you will actually be running when we bring you back here to Delhi Tech for the hands-on portion. They're still debating when to do it. I'll let you know as soon as I hear. You may hear.
Do they have it narrowed down to a couple different times? Like, is there anything you can tell us?
No, because everything's up in the air. Once they tell me that it's definitive, then I'll tell you.
Okay.
One thing I do want you to think about, and I'll give you input, is I'd rather give you the soils test after you've run these. In other words, the soils test is the last hourly. And I'd rather give you that test after you have run all 3 of the laboratory experiments. I think you'll do better on the test. In other words, I would give that to you here at Delhi after we're done with all the soils, because that's the only test that we have left is the soil. So think about that. I could either give you the test during finals week, or I could give you the test when we bring you back at the end of our hands-on labs. Same thing with surveying, but we'll talk about that next Monday night. So we're going to go over the actual running the test. This is what I typically do in the lecture. It's just nice because I've got all the stuff to show you. And we're going to show you where the data comes from. And one of you had emailed me, and I got to get back to you, and I will, about where to look for a job. I would consider, some of you are out of state, most of you are in state. Check with testing companies. They're starting to see an uptick in the amount of work that is essential. And they may be looking for technicians to test concrete and to test soil. So I'd be more than happy to give you some pointers on that if you do in fact go to one of the testing companies. And just look up material testing labs in your area on Google. I don't want to give any names because I'm recording this, but if any of you are interested, send me an email and I will get back to you. One of you did, and that's what made me think about it. So in this folder, what we've given you is the Civ Classify handout, which I have right here. And so the pages here are the actual data sheets that you're going to do in the lab. And we're going to go through these tonight. And then here's the graph. And I just plotted on my big plotter this graph. So we'll play around with that as well. So there's 2 soil samples that we're going to analyze using the grain size analysis testing, which is the sieve. And then we're going to get into what they call soil classification. And a little bit of background. You don't have this. It's really in its infant stages. I'll give you the first 2 pages. Here are the ASTMs for the sieve test. Well, that might be C136. I can't remember that. but I'll get those exact numbers. And then D 2487 is the classification of soils for engineering purposes. In other words, why do we classify soils? To determine if we can use it for the specific project. The specs will tell us. If it's a dam project, we got to have a cohesive soil. The second reason for classification, how can the soil deal with the loads that it's going to see? Is it supporting a building, a road, a bridge, a tunnel, etc.? On the Delaware Aqueduct bypass tunnel under the Hudson River, they have full-time geologists on staff just to see the consistency of the rock that they're drilling through. Also drainage, right? If you're building a dam project, you don't want a lot of you don't want any drainage through that pond, if you will. Frost action. Is it susceptible to frost, which is going to heave it? Now, the soils, we talked a little bit. A boulder is retained by a 12-inch sieve. It's so big it can't get through an opening 12 inches square, 12 by 12. A cobble will go through that 12-inch. Whoops, we got some people in the waiting room. The cobble will go through the 12-inch sieve. But it's going to be retained by a 3-inch sieve. Now, gravel will go through that 3-inch sieve, but it's going to be that particle, and again, we're talking about a sample of soil that has many different size ranges. So these sieves give you a range of sizes. I'm not going to measure each individual soil grain, if you will. So the gravel goes through the 3-inch sieve, and it's retained by the number 4 sieve. Now, when it gets into the numbered sieves, you take whatever number you're dealing with and you square it. So that means that there's 16 openings per square inch of the sieve for a number 4 sieve. Now, a sand particle will pass through that number 4 sieve, but it's going to be retained by what we call the number 200 sieve. And the 200 sieve has 40,000 openings per square inch. And anything that passes, oh my heavens, how did I put that? Everything that passes the 200 sieve is a silt or a clay. Okay? And again, for sieves with a number, square the sieve number, and that's the number of openings per square inch on the sieve mesh. And what we're going to do now is take a look at a YouTube. Hopefully you have you've watched it. We're just going to watch a little bit of it just to give you a feel for what we're going to do here. So I manage this. Oh, a new share. And we're going to share the computer sound. So you should hear the sound. Can you still hear me?
Yep.
Yep.
So this is me when I was younger. Just kidding.
We're going to go over the laboratory procedures used for particle size analysis. This short video will demonstrate how to conduct particle size analysis.
Can you hear him at
in
all?
accordance with ASTM specifications.
Quiet. Yeah.
Yeah.
Size analysis is used by geotechnical engineers to help easily classify soils. The particle size analysis consists of 2 procedures. The mechanical sieve analysis involves the use of a series of mechanical sieves to help determine the grain size distribution within the coarse grain fraction of the soil. A hydrometer analysis is conducted on the fine grain portion of the material. Material that passes the number 200 sieve is considered fine grain material. The resulting curves from these 2 tests can be used to characterize a soil and used to reject or accept the material for engineering applications. The practical applications of the particle size analysis in geotechnical engineering include soil description, quantitative soil classification, and correlations to permeability based on the Hazen's equation. The devices required in order to conduct a mechanical sieve analysis are a stack of sieves ranging from number 4 to number 200, 4, 10, 20, 40, 100, 200, the pan, and a lid, a mechanical shaker, a digital balance, and a weighing bowl. In order to conduct the hydrometer analysis, the following devices will be required. A 1,000 milliliter sedimentation jar.
The hydrometer is used to differentiate or tell the difference between silt particles and clay particles. We're not going to do it, but he's going to give you a quick 1-minute description.
1,000 milliliter control jar, an ASTM 152H hydrometer, a soil dispersion device, in this case a shake mixer, a soil dispersion agent, in this case sodium hexametaphosphate, a squirt bottle filled with water, an evaporation dish, a rubber stopper, and a thermometer measuring in Celsius. The soil that we will be performing the particle size analysis test on is a well seal silt that was obtained from the Mississippi River Valley. The soil has been mechanically pulverized. Some coarse material has been added to the silt for the purpose of this lab. The documents pertaining to today's lab can be found on Blackboard in PDF format. The particle size analysis is part of a combination lab handout entitled CE 215, Lab Number 3 and 4, Index Tests and Classification of Soils. In addition, ASTM standards of the two tests have been posted on Blackboard. ASTM C136 pertains to the sieve analysis of fine and coarse grain aggregates by the mechanical sieve. ASTM D422 pertains to the hydrometer test. Also available is a data sheet for today's lab. A sieve analysis is conducted to determine the particle size distribution curve, or gradation curve. The particle size distribution curve is a plot of the percentage of soil particles finer versus the log of the particle diameter. To determine this, a soil sample is shaken through a series of sieves. The mass of the soil retained on each sieve is then determined. From this, the percentage passing can be determined. Start by weighing out a sample of 500 grams of the provided air-dry soil. Start by weighing out a 500 gram sample of the provided air-dried soil. It is important to mix the sample in between each scoop so that the 500 gram sample of soil is an accurate representation of the provided soil sample. Record the total mass on the data sheet. Disassemble the stack of sieves.
Okay, so as we go through each step, let's go back to the handout. So I'll have this. This is the handout that I've given you on Vanco. Now, if you don't have the capability to print this, when you do the homework, all I want is this part. I don't want you to do this part. This is always filled out. In other words, the name, the location, the soil description, the sampling method. Remember we talked about stockpiles, conveyors, transportation units are actually at grade. Okay, that's what they mean by sampling method. That was in the soils flow chart. So did you test at the base, from a conveyor, from a dump truck, if you will? That's what they mean about that. If you'll notice down here, you've got weight of the dry soil plus the dish. So that's the total weight of the dirt, the soil, and the dish. This is your homework example. And then the dish weighs 323.0 grams. Now, since it snowed the other night and I lost power Sunday night from 10 p.m. to 3 a.m., with all that snow, I felt, well, that's close to Christmas. So what we've done for you is we have given you this Excel, which is in that same folder as the data sheet that we just opened up. So you're going to be able to check all your homework to get it 100% correct. And I got to keep moving this little bugger all the time. So if you'll notice, here's an example of a test, and we're giving you all the numbers. So this right here is this. Okay. I got to give you students credit. They made this for me years ago. So here's all the sieves that we're using. Now he only started, I believe, with the number 4 sieve down to the 200. The pan is what catches the silts and clays that go through, that pass through the number 200 sieve. So we've got a bunch more. And then this is the data that you're going to enter. So the first thing we had was, am I recording? Yep. Sorry. The first thing we're going to do is we're going to make this a little bit bigger. And we had the weight of the dry soil plus the dish, which is, I'm just looking over. I've got a paper copy here. What is that? What's that? 455. Yeah, 455. Okay. So this is 455.2. And actually, I'm jumping ahead of myself. Forget what I just said. We had the weight of the soil was 1302. Am I typing in the right numbers? Yep, 1302.2. And then the weight of the dish was 323.0. Now, I don't know why that hasn't, so that's equals, oh, I wonder. That should have been, so that equals this minus this. Okay. 979.2 grams. Now that should burp up into here, yes. Okay, so there's your weight of your soil, which is the same as this. Okay, so that's what he just did. So let's go back and see what else he's going to do after this.
And brush out the wedged particles in the screens. Do not use the sieve brush on the number 200 sieve, for this could damage the screen, with the smallest sieve on the bottom, in this case the number 200. Pour the soil sample into the top of the sieves.
Now, he didn't show that he weighed those sieves. That's what we're going to show you in a minute here.
Place the lid on top of the stack of sieves, and with 2 hands, carry the sieve stack into the shaker room. Load the stack of sieves into the mechanical sieve shaker. Place the shaker lid on top of the stack of sieves. Lower the shaker hammer and turn on for 10 minutes.
Kind of got a rhythm, don't you think?
Remove the shaker hammer, take off the shaker lid, and with 2 hands, remove the stack of sieves from the shaker and carry into the other room. Empty the material in the pan in a bowl and record the weight. This material is the material that has passed the number 200 sieve. It is considered the fine-grained portion of this material. This material will be used in the hydrometer analysis portion of this lab. Compute the total retained mass by adding the individual masses retained on each sieve in the pan. The total mass should be within plus or minus 2% of the original mass.
Okay, that soil that goes through the 200, again, is a silt or a clay, and it has the texture of baby powder. Literally feels like baby powder. The sands and gravels are gritty because they are what they call coarse-grained soils. Silts and clays are fine-grained soils. So if we go back to our data sheet, okay, 588. So we had 455.2. I'm just going to do a couple. 625.3, 566.3. These are 0.5. These are all the.
There might be people in the waiting room.
Oh, I don't see anybody.
They might have left then.
Oh, damn it! Sorry about that. So 566, then they got 585.7. So you're just going to be adding these numbers, and then we'll do one more. 529.2 is the number 4 sieve. Okay. This really should have a number in front of it. Hashtag for you guys. Now, so what he did is he had put all of that soil into that stack of sieves, right? Let's back it up just a little bit. So he put that soil in that stack of sieves. He then put it in the shaker for 10 minutes. And so the shaker is causing the soils to kind of jump around in those sieves. And then they find their final sieve, if you will. So this is a range of soil particles, okay, as you go through this test. Then what he's doing is he's breaking them down, and then he's going to weigh each of those sieves individually. And so the weight of after he weighs it, it's the weight of the sieve plus the soil. So column 1 is the sieve number or sieve size, 2 inch. Then you get into the numbered sieves, the sieve weight, and then after shake and bake, that was a joke. This was 455.2, which meant that all of the soil sample, went through that 2-inch sieve. So there was no soil retained because column 4 is column 3 minus column 2. The next one is 625.3. Now, a question that usually happens, and the students say, well, does the weight of the sieve show any pattern? No, it does not. So don't worry about what the sieve weighs. This is all empty. This is just the sieve with no soil in it. This is after the soil has been sieved or shook, whatever, through that sample. So this is still 0, and then that's 566.3.5. So we have nothing retained on the 2-inch, the 1-inch, and the 1.5-inch sieve. Now, when we get into the 1/4-inch sieve, now we see that the weight of the sieve plus the soil is 624.1. So these numbers are burping out for you. Okay. And you can see that the percentages, everything is being calculated. And if you look, look up in here. There's the formula. So these are yours to keep. I would advise you, if you go into the bachelor's program, to take, and it might even be required now, to take advanced Excel. I'm telling you, it's a moneymaker. It really is. It's a good course. Ms. Clifford and Ms. Poole teach that course now. So again, we'll do one more. The number 4 sieve is 678.7. That meant that there was 149.5 grams of soil that's literally sitting on the top of that sieve. And if we go to the data sheet, you're wondering where this is all coming from. It's all these numbers right here. There was that 678.7. So you're basically going to plug and chug these numbers into this Excel. Now the homework is going to be that you got to write this out by hand, the whole thing, all of the data. Not going to take you that long. It'll just make you see where the data is coming from. And then here's the how to, and then you'll be able to analyze it versus the results from the Excel. What we're going to have you do is probably show the calculations for 2 sieves. In other words, for the number 4 sieve, you got to show all the calcs for column 4, column 5, 6, and 7. But you're going to have the formulas in the Excel. And that's why I've started giving the Excel to you. Let's do a number 10, 439.3 and 755.7. I mean, that's a lot of grams out of the 9, close to 1,000 grams. About 30% was retained by the number 10 sieve. So if you look at column 5, and he doesn't go into any of these calcs on the YouTube. Column 5 is column 4 plus column 5 of the previous line. So let's take one that kind of makes sense. Column 5 is column 4 plus column 5 of the previous line. So let's see what the formula is up here. So that's Q10. So we're actually doing a little backwards. We're taking column 5 from the previous line plus column 4. So you could say this plus this equals this. This number plus this equals this, and so on. So again, 38.4 is column 4, which is P11, plus column 5 from the previous line, which is Q10. These are called cells. And you've had you folks had some Excel that Mr. Oltanius taught you in orientation, didn't you? So this is just a super powerful program. And basically you just plug and chug the rest of these numbers. So are you with me on column 5? It's nothing more than column 4 of that same line plus column 5 of the previous line. Now column 6 is whatever we got in column 5 divided by the total weight of the sample. Okay, the total weight of the sample. Now, real quick, when you get all of column 4 weighed up, see how I said summation of column 4, this number should be within 2% of this number. And 398.4 So you'll see how this number is changing, 594.7. So this summation of this column is getting closer to the 979.2, which is the weight of the soil. Okay. So let's go to column 6. All of this, you know, these were all zeros. That makes sense. But this one is column 6 is column 5 divided by the total weight. Okay. And this is column, so Q11 is right here, Q11, which is column 5, divided by R2, which is over here. Now, there's a dollar sign. You see where there's a dollar sign, then R, then dollar sign, then 2. That means that it's always going to pick that number, okay? So again, 384.4. 384.4 divided by 979.2 is 0.39. Let's see, 380. Oh, 38.4. Got my decimal. 979.2. Shoot, is 0.039. And then you'll notice up here, this is a percentage. So that's why it burps it automatically into percent for you. So you know what that means? That means that if you had 100 pounds of sample, or close to 1,000, that, let's say you had 100 pounds of sample, almost 4 pounds would be the cumulative percent retained. And then, in other words, everything above the 1/4 inch sieve holds about 3.9% of the total sample size. Does that make sense or not? That's the word cumulative. That's key. Cumulative soil weight retained, cumulative percent retained. You go down to here. This 19.2 is 187.9 divided by 979. So 187.9 divided by 979.2, and that's 19.2%. Now, what we really want is the percent passing. We want to know what percent of that sample size, that 979.2 grams, passed any of the sieves. Okay, that's critical. We use that to classify soils. Is it a clay? Is it a silt? And so on. Okay? So if you look over here at the example that we've given you, it makes sense that in column 6, by the time you get to the pan, 100% of that sample has already been retained by the other sieves. It also makes sense that 0% passes the pan. That's because there's no holes in it. It's literally a pan. It's to catch the silts and clays that pass the 200 sieve. So this percent passing, column 7, is what we want as they relate to the sieve size. Okay. So you get to use this. This is yours to keep. Oh, take a look at this. Column 4 added up. See where it says summation? See them right here. The sum, F8, this is F, this is 8. all the way down to F18 gives me 1199.7. I started out with 1200.1, and it's a 0.03% error. I think you're allowed up to a 2% error, so that's very good data. So this is where the curve comes in. This is where the curve comes in, which is this right here. So this curve, and I'm going to do this manually. Like I said, I plotted this curve on my plotter. Right here, this is percent passing by weight. That's column 7 from our data sheet. This is percent retained by weight. That's column 6, but column 7 is what we want. But it kind of makes sense. If 60% passed the sieve, if you go across here, over to here, if 60% passed, 40% had to be retained. So don't worry about this one. It's this y-axis that is column 7. Now look up here. U.S. standard sieve size opening in inches, U.S. standard sieve numbers. The number 3, which we don't use, we start with number 4 all the way to the 200. And there's the hydrometer. Down below, it's the millimeters. Now, this is what we call a logarithmic curve or a logarithmic graph. When you do this, if you cannot make a photocopy of this, just do the best you can, okay? But just give me something. Now, this is a 1-inch opening. How many, do you remember how many millimeters are in an inch? Anybody? .4. So if you come all the way down to here, right, it's right about here. Being a logarithmic curve, it is not a consistent increment. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is 10, 20, so 25.4 hits between here. If you move that up, if I can stop shaking, there's your 1-inch sieve. Okay. The 10 sieve is about how many millimeters? 2. So that's 1, 2, 3, 4, whoops, and 5. So let's graph this example right here. And let's make this a little bit bigger. So what we're going to do is the first 3 I'm going to plot right away. That way I can show you. So the 2-inch sieve has 100% passing. The 1-inch sieve has 100% passing. I gotta turn on more lights here. What's the percent passing for the 1/2 inch? All of the sample went through the 1/2 inch. So here's the 1/2 inch. And you'll see my 3 marks. The next one is the 1/4 inch. Okay. And that's 96.8. So, I want you guys, Let me see, I might take a picture of that. Okay, so now I'm going to switch my my screen, and I'm going to go with the camera. You tell me if you can see my whiteboard. Go Mets. So let's move this a little closer. Still give me room to, so right here, there was the 2-inch sieve. Here's all your sieve sizes. Here's your column 7. This is data sheet, column 7. The percent passing. Okay. So we had seen, I'm looking at my, so the 1/4 inch was about 96. So the 1/4 inch, which is right around here, is about 96. So you make an X. 1/4 inch, 96. 2, 4, 6, just ballpark it, because again, it's a logarithmic curve. It's a bit of a pain. The number 4 sieve is 89.8 passing. That's about 90. So the number 4, I'm going to do these in different colors. Number 4 was about 90. Can any of you see what the number 10 is? Or do you have to go back to the other? Can you guys hear me? Can anybody?
Yeah, we can hear you.
Okay, phew, thought I lost you. So I'll read it off. The number 10 is around 52%. So here's the number 10 sieve, right? Here's 52. There's your data point. I do these in different colors. Number 10, 52%. There's your data point. The next one is the number 20, which is 26.5. Number 20 is 26.5. Okay. And the number 40 is 13.1. The number 40 sieve is 13.1, which is right around here. And then the number 100 is around 2. The 100 sieve, just 2%. And then the percent passing the number 200 sieve is only 0.5%. The number 200 sieve, 0.5% is almost at the bottom, and that's your last data point. So, what we have here is a series of data points on the curve. Percent passing versus sieve size. And now the fun part, guess what you get to do? Connect the dots. Isn't that amazing? So that is your gradation curve. It's the graph, it's the curve of the soil. So that's what you're going to do for one of the samples. And I'll put this on Vanco tonight or tomorrow morning. Our next Vanco is when? Thursday night?
Yes, sir.
So how about I make this due Thursday around 2. Okay, that gives you a couple days to do this. So let me write that down so I don't forget. So this is Thursday. So that's Thursday the 30th at 2 p.m. Okay. Let's see here. So let's go back to share screen. Okay, so move my big desk here. And there is a soil handout that we gave you. Now, the ones for the homework are in this week's block on Vanco. But there is at the top another folder of soils info. And this was the soils handout number 1, the sieve. And I believe this is the one that shows, I hope, yep. So we're gonna do this in a different view. There you go. So this is the one that you see right here. Oh, shit, I gotta get my phone. So right here, the well-graded is like a gradual curve pretty much along all of most of the sieve sizes. When you ever see a curve that starts to go a little bit horizontal, the slope is decreasing right in here. Okay, that's called gap graded. And gap graded means poorly graded, which means one of the sieves, 1 or 2 or more of the sieves, did not have a lot of soil retained in it. So that's what they mean by gap graded. And then uniformly graded means what? What do you think uniformly graded means? Give me an example of a uniformly graded soil. Think of concrete. What are the ingredients in concrete?
Lime, water, and cement.
Oh, give me the aggregates. Give me the soil. What soil? What inorganic soil goes in concrete? Ooh.
Gravel.
Yep. We got sand and stone. So the sand would be, say, a well-graded sand. It would not have a very high percentage passing the 200 sieve because silts and clays are terrible for concrete. They're so fine that they can coat the crushed stone particles with like a film of dust. And that prevents the bond between the cement paste and the stone. So the well-graded would be your cement, your concrete sand, and your uniformly graded would be, say, your 1-inch stone, okay? Or all 1/2-inch stone, or all 3/8-inch stone if you're using a concrete for grout in a concrete block wall. So that's what they mean by uniformly graded. For the most part, the vast majority of the sample is a consistent size. So that's a good example of the different types of curves, like what we just plotted. And then the hydrometer, I'm going to go back to that video and see if he went to a, let's see, he's going to, yeah, he's close here. But he's got to shake it up first. He hasn't shook it up yet. So let's start this.
After the 15-minute soaking period, transfer sodium hexametaphosphate soil
Nice.
solution.
This test literally takes days.
Into a clean sedimentation jar.
So what he has there is a slurry of
Again,
sample.
using a squirt bottle with water,
He uses a
ensure
reagent.
that all the sediment has transferred from the dispersion cup into the sedimentation jar. Cap the cylinder with the rubber stopper. Agitate the solution for 1 minute by turning the cylinder upside down and back 30 times in 1 minute.
So all he's doing is he's putting the silt and clays into suspension. He uses a chemical that keeps them in suspension.
After 1 minute of agitation, remove the rubber cap and use your water squirt bottle to ensure that all of the sediment is off the cap as well as off the sides of the sedimentation jar. Fill the sediment solution up till it is at the 1,000 milliliter mark. Place the sedimentation jar on a table where it will sit undisturbed for the next 24 hours. After 2 minutes of placing the jar on the table, insert your hydrometer and take the first reading at 2 minutes.
It's all based on specific gravity.
Record the reading on the hydrometer staff at the top of the meniscus of the dirty water. After the reading, remove the hydrometer, place it aside, and insert the thermometer to take a temperature reading.
And all of this data goes into a computer program.
Continue recording the hydrometer and temperature readings at approximate elapsed times of 4, 8, 16, 30 minutes, 1, 2, 4, 8, and 24 hours. From the hydrometer time history, a gradation of the particles falling out of the solution can be calculated. That, combined with the particle distribution curve determined from the mechanical sieve, will give a full grain size distribution of the provided soil.
Isn't that amazing? So this part is what we just did with the sieve. And then anything passing the 200 is what he just did with the hydrometer. Okay. So what we've done today is we've shown you how to do the sieve test, showed you a little bit of the hydrometer. There's actually one other test that is used to differentiate between silts and clays, and that is what they call the Atterberg limits, liquid limit and plastic limit. So your homework for Thursday by 2 o'clock, I think I can get it graded by the time 6:30 rolls around, is to, where the hell is it here? You're going for soil A. Whoops, we're going to go back to rotate the view. So for soil A, you're going to show me this completed chart right here. Okay? If you can make a copy of that, it's got to be all handwritten to get credit. If you can't make a copy, don't write this stuff down. Just do the data. Okay? You don't have to write this down, but you do have to write this down. But all of you have the Excel. Okay? So you're going to have the right numbers because you'll be able to burp all of this in. Okay? And get all the correct numbers. Then what you're going to do is you're going to write down all the numbers by hand, And then let's pick, let's pick the number 4 and the number 200 and show me the calcs. So you're going to, like for the number 4, you're going to say, you're going to write out 678.7 minus 529.2 equals 149.5. For this number, this was column 5 or row 5 from the previous line, or column 5 from the previous line plus column 4. So there you're going to show me 38.4 plus 149.5 equals 187.9. Then you're going to show me 187.9 divided by 979.2
Wow.
times
Good
100
right after
is going to give you 19.2%. Now, if 19.2% is retained, guess what? 100% minus 19.2 will give you column 7. And that's what that is. So column 7 is equal to 100% minus column 6. So getting back to the number 4, see, 100% up here minus R12. R12 is 80.8. So give me the number 4. I better write this down. So the number 4 and the number 200. And then I want column 7. I want column 7 plotted on the curve. And if I can find that damn curve. And so there's the curve. So column 7 versus the sieves. And that's the homework that's due for Thursday at 2 o'clock. Plus the graph. Just making myself some notes. Okay, so data sheet, data by hand, the calcs and the graph. And then when you come back and whenever you come back, God, I can't wait till you come back, then we'll actually run this damn test. Pretty cool. Like I said, you know how to test concrete. You're starting to learn how to test soils. You've got some skills there. You never know, who might need some beginning technicians. Any questions? I can tell you're all riveted. Okay. So no questions. So I'm going to stop the recording for the Zoom lecture for Tuesday, April 28th from 7:30 to 8:30. I do appreciate your patience. And as I've always said, hope you and your family are all well.